Okay, today I want to talk about a voltage tester. This is made by a company called NOP. This is commonly called a Wiggy. It is able to measure the approximate voltages between about 100 volts to about 600 volts. This will work on both DC and AC. It is not a precision instrument. It won't tell you, for example, if you have 115 volts versus 122 volts versus 128 volts. If you need that kind of precision, if you are doing some troubleshooting, then you are much better off using a digital multimeter. In line work, we typically use these meters for verifying the voltage on newly installed transformers, or we may also use these to check a meter base prior to slugging or to putting a meter on. These are very useful for the meter check. They are a low impedance device, which means they will not give you a ghost or phantom voltage that some other meters may give you sometimes. So these are much more of a go or no-go check, much simpler. I'm going to show you now how different voltage measurements look on this device. So right now I'm going to put on 120 volts. So right here you can see a line comes down about the 120 line right there. Now on the right side, these are all approximate voltages in AC. On the left side, these are the approximate voltages in DC. So when I test 120, the line is about the 120 mark. I will show you how it looks when you test 208 volts. So for example, if you are checking the voltage on a newly installed 120 208 Y bank, or maybe even when you have a newly installed open delta, a 120 240 open delta with a 208 volt high leg or wild leg. And this is how that wild leg or high leg would look. So the line is right here. You can see the line is much more than 120, but not quite to 240. And finally, I will show you how it looks to measure 240. So if you're measuring 240 on a newly installed transformer, a 120 240, this is your 240, or maybe even on your open delta, a 120 240 open delta, this is your lighting load, 240. So you can see the line here is about 240 volts. So you may have noticed that the difference between 208 and 240 on this dial was not that much. I can tell you that especially when you are measuring one versus the other, so on that open delta scenario where you are measuring both 240 and 208 in the hand, it is very clear which is the 240 and which is the 208. The 240 hits much harder than the 208, so even though it may not be very apparent on here, when you're actually using this meter, it is pretty clear. So I'm going to show you now how this tool actually works. So what we have is two leads, and when we are measuring something and measuring a voltage, putting a voltage across these two leads, these leads lead into the meter itself. In the front here we have a small neon lamp. In the back there's a small resistor, but ultimately this is what is doing the work. This is a coil of wire, and when we place a voltage between these two leads, we are going to generate a current within this coil, and that current is going to produce a magnetic field, which is then going to pull in this ferrous rod into the center of the coil. It's made of steel. There's a small spring that is resisting that rod being pulled in here. So the greater the current, the more it's going to pull in, and the more it's going to pull in, the more the spring is going to resist. So I will show you how it looks when we measure 120 volts on here. So it's about 120 right there. And you can see that kind of pulls down there. The neon lamp on the bottom is lit up and the rod got pulled down slightly. When I let go, when I come off here and stop measuring voltage, current stops, so does the magnetic field, and the indicator goes back to where the spring wants it to go. So that was 120. So this here is 240. So higher voltage, higher current, stronger magnetic field. I would expect this rod to be pulled down further. And when we do this, it pulled down enough for it to bounce right back up again. So that is roughly how these work. One important note I didn't mention earlier is that these have a pretty light duty cycle. So I will measure the 240 again. So I'll pull down stronger. These are not designed to be continuously run. So they don't like to hold this here. We can actually cook this coil and break this tool. So they are designed to be run just momentarily, real quick, for a few seconds at a time, not for minutes at a time. That is not really an issue for line. We're not really holding on, measuring a voltage consistently for minutes. Generally, we are checking a voltage in a few seconds, and yeah, that's 120. Yeah, that's 208. Yeah, that's 240, and letting go. But that is something to note.